Okay, we just talked a little bit about recursion formulas. Now we're going to use some. These formulas, these sequences are defined recursively. We are asked to write the first 4 terms of the sequence defined by. If your A1 is 12, then to get your next number, whatever it is, if I wanted to get A2, then I would do A2 minus 1, which is 1, which is telling you go to the previous one and add 4 to it. Okay, so let's just say I'm gonna fill in an example here. If I were asked to find A sub 10, this would say I go look at 10 minus 1, which would be A sub 9, which would be the number previous, and then add 4 to it. Okay, now here you're asked to find the first 4 terms, and they give you your first term. It's a freebie. Your A1 is equal to 12. Now to find A sub 2, this says I go find A1 and then I add 4 to it. So this is 12 plus 4, which is 16. Okay, now let's find A sub 3. This would be A, 3 minus 1 is 2, so I go to A2 and then I add 4. So this would be A2 is 16 plus 4, which would be 20. And then A sub 4, which is the last one we're supposed to do, we would go find A to the 4 minus 1, so that's of 3, A3, plus 4, and A3 was 20, plus 4 is 24. So the first 4 numbers in this sequence are 12, 16, 20, 24, and so on. Now the one part of this recursion formula that I didn't talk about was right here. And that's because we're only allowed to plug in numbers 1 through whatever, only integers, only positive whole numbers. But we can't plug in 1 because it's given to us. So this is just saying that the first number we're plugging in is 2, because that's the first one. We don't know A2. That's the first one we don't know. All right, so let's look at another one. We want to write the first 4 terms of this sequence, where your first term is 5, and then to find your next term, you're going to see the previous one, multiply it by 3, and then subtract 1. Okay. So A1 is given to us, it's 5. So to find A2, we go to the previous one, which is 5. This is going to be 3 times A1 minus 1. So 3 times 5 minus 1, 15 minus 1 would be 14. Now find A3. This will be 3 times 3 minus 1 is 2, so I go find A2 minus 1. And this is 3 times A2 was 14 minus 1. And this is 42 minus 1, so this is 41. One more, I want to find A4. So this will be 3 times the previous one, which is A3, minus 1. So this is 3 times 41 minus 1. This is 123 minus 1. This is 122. So this is how recursion formulas work. You're given at least one starting point, and then you're giving a rule to get other parts of the sequence. Okay, so now let's talk about factorial notation. We use the exclamation point for factorial notation. Now, by definition, 0 factorial is equal to 1. This is by definition. Okay? Now, here's how normal factorial notations work. All right, what this is saying, notice here's that same number, This is 1 less, this is 2 less, and then I'd go 3 less, 4 less, 5 less, until I get down to 1. So what this is saying is if I'm asked to find 5 factorial, this is 5 times 4 times 3 times 2 times 1. Okay? Now these calculators have a factorial button on them, and they are this one calculator is right here. It's sometimes hidden under a probability button, a probability menu. So if you don't see the exclamation point somewhere, just look under a probability or something, okay? If I wanted to find 5 factorial, I'd hit 5 and then that button, and it's going to tell me it's 120. So it does these calculations for you. Now the thing is, factorials grow extremely quickly, okay? So here's my 5 factorial. Let's look at 10 factorial. Quite a bit bigger, right? And then 20. It's overflow now. It's into scientific notation. I shouldn't say overflow. But I can go up to, let's see, 60 factorial. My exponent, my scientific notation, this would be times 10 to the 81st power. It's really huge. And I can do 69 factorial and get an answer. But if I try 70 factorial, these calculators can't handle it. So that's how quickly these things grow. Now, I mentioned probability, and if you're going into that field, you're going to be using factorials a whole lot. So, and they often come up in sequences and series. So let's look at right here. I want to simplify 18 factorial over 16 factorial. Now I can enter this directly into my calculator if I wish. Clear. 18 factorial divided by 16 factorial, and I get 306. Okay, so I can do that. But there is a trick you want to recognize here, because it is possible that you are asked to simplify a factorial that involves a number that's too big for your calculator to compute. So we have to recognize what's going on here. I'm going to write down the definition. This would be 18 factorial is 18 times 17 times 16 and so on, right? All the way down to 1. 16 factorial is 16 times 15 times 14 all the way down to 1. Well, notice what's going to happen here. From here down, it's exactly the same as this, right? This would be 16 times 15 times 14 all the way down to 1, and that's exactly what I have here. So these cancel out, and your answer is simply 18 times 17. 18 times 17 is 306. Now the way we often write this, we don't write it out this much. We go 18 times 17 times, and then we just sort of stop and do 16 factorial. This is shorthand for the rest of it. Anytime you have a factorial, you can do this. You can list a few numbers and then just list the factorial further down. If you put this over 16 factorial, it's much easier to see that they cancel. Okay? So let's use this in a sequence. We want to write down the first 4 terms of the sequence defined by a sub n is equal to n plus 1 factorial over n squared. So this is defined regularly, not recursively, so we need to find a1. This is going to be equal to, I'm just going to write out every step here, 1 plus 1 factorial over 1 squared. Well, this is going to be 2 factorial over 1. 2 factorial is 2 times 1, which is 2. Okay, A2. This is going to be 2 plus 1 factorial over 2 squared. Okay, so this is 3 factorial over 4. What is 3 factorial? It's going to be 3 times 2 times 1, which is 6. So this is 6 over 4, which reduces to 3 halves. A3 is going to be 3 plus 1 factorial over 3 squared. So this is 4 factorial over 9. Notice that 2 factorial was 2, and then 2 times, we went up by 1, so now this is by 3, and I got the 6. 6 times 4 is 24, and you can check that. 4 factorial is 24. Over 9, 24 over 9, these are both divisible by a 3, so you get 8 thirds. Now one more, A4. So this is going to be 4 plus 1 factorial over 4 squared. So 5 factorial over 16. So this is going to be 24 times 5. It's always your previous factorial times the next number you're adding to it or multiplying by. So this is 120, and we already figured that out actually. 120 over 16. And this reduces, actually, I believe both of these are divisible by 8. I know 16 is. 120 divided by 8 is 15. Okay, so this is 15 halves. So the first 4 numbers of this sequence are 2, 3 halves, 8 thirds, 15 halves, and it will continue. Okay?